Hi, everyone. My name's Scott Piper, and I'm going to talk to you about the State of the Cloud report that I produced along with Amitai for Wiz. Both Amitai and myself are each on the threat research team at Wiz. And so this report looked at some of the information, some of the data that we end up getting as a cloud security company, and also looked at a lot of other public information, a lot of information that hit the news. And we just want to talk about just kind of generally what has been happening in the world of cloud. And so this report is actually kind of unique, I feel like, in that we don't talk in this report about, it's not really a sales pitch or anything. It's not, us trying to say, here's what we see and here's how our product fixes that for you. This is just generally good information that we think that is going to be valuable to anybody that is using the cloud today. So the main guts of it starts at the year in review here. So this is where we looked at what we thought was important news. Obviously, we're going to be very biased, so some of this news is things that were relevant to us. But in 2021, so this report is really about what has happened over the past year in 2022. But what happened in 2021 was suddenly Wiz and some other researchers started finding cross-tenant vulnerabilities in the different cloud providers themselves. This is like scary, super critical issues where they were able to, from within their account or subscription or whatever the different cloud providers call it for themselves, our researchers were able to compromise the data of another account. So potentially another customer or something like that. Both our researchers and other researchers that were doing these type of activities did it in a way in which they were only accessing other accounts that they owned, where possible. Sometimes it wasn't possible, unfortunately. But in this research, what they did though was they were able to find these vulnerabilities, which is super scary. And so, as kind of an offshoot of that, there was this public repository that I started creating before I joined Wiz, which ultimately became the Cloud VulnDB project, which is now underneath Wiz's umbrella. And what this project did is and continues to do is to basically collect data points on all the different security mistakes that the cloud providers are making. So one of the main goals was to identify these different vulnerabilities that were happening, and especially because in some cases, when those vulnerabilities are identified, customers have needed to take action in some way. And there wasn't really a good way of knowing what were the actions that you might need to take. And so this would be things like potentially rolling your access keys or other types of steps that you need to be taking in your environment. So Cloud VulnDB was collecting all of these different incidents or other types of things that happened. Some of these issues are things from SOC 2 reports from the different cloud providers. So it's all sorts of different issues. Basically, anytime that we kind of viewed anything as being potentially a mistake in some way that's security related, we included it into this database. From that database, then we end up creating this thing called the Peach Cloud Isolation Framework. And so what this is basically our guidance from looking at the different issues in Cloud VulnDB and looking at the different cross-tenant issues that have been found by our vulnerability research team, and basically trying to figure out what is guidance that we want the cloud providers to be following in order to ensure that those cross-tenant vulnerabilities can't happen again. And this is guidance that not only works for the cloud providers themselves, but really anybody offering a SaaS solution that has multiple tenants inside an environment in some way. And you want to ensure that each of those tenants is isolated so that if somebody, has admin privileges within their own tenant environment there, whatever admin happens to mean for that, environment, that they're not able to leverage that in some way in order to access the data of another tenant in their environment. So this is guidance that we follow for our own product. We also believe that the different cloud providers should be following it, and then also just anybody else with any type of SaaS solution should be following this type of guidance as well. So the other important thing in the news was basically the Lapsus, is a threat actor out there. They started to actually make use of the cloud environments in some way, moving laterally between them. And so this is something that hadn't really been seen before from various attackers out there. is they weren't really using the cloud. There's been a couple cases where you have had attackers that knew what they were doing in cloud environments. An example of that is in 2019, the Capital One breach happened from the attacker involved in that was a former AWS employee, unfortunately, and so they knew what they were doing. But other than that, really a lot of the attackers have been kind of opportunistic, or they have been using their access solely for cryptocurrency mining. And so they haven't, you haven't really had these attack groups that knew how to do things like phishing and other types of, general attacks, and also knew what they were doing in the cloud. So Lapsus Group was kind of, one of the first attack groups that really showed that not only can they do all those other types of attacks, but they also know what they're doing in a cloud environment as well. The other thing that has happened in the news was I believe IMDS-v2 ended up gaining a lot of prominence, a lot more importance to folks. And so IMDS-v2, or Instance Metadata Service 2, this is something that came out for AWS in the wake of the Capital One breach. There were some issues identified with the Instance Metadata Service that could be improved. And so they released this new version. And so from that, there were a couple things that happened. One, there was a new guard duty detection that was able to detect when IAM role credentials are being used from another account, or from somewhere else outside of that EC2. This is something that people had been wanting forever. I think Will Bankston was maybe one of the first people to like publicly call this out. The AWS need to improve on this. And so this is something that AWS now has with the guard duty service that has been improved in order to detect that. I personally am very biased that the IMDS v2 service gained a lot of prominence because I was involved in a number of aspects of this prior to me joining Wiz. So I was able to encourage and motivate a number of vendors to start allowing people to enforce IMDS v2. So previously, some of these vendors, their solutions didn't work if you were trying to enforce IMDS v2. So now luckily they are. There was also a case of a threat actor, this UNC 2903, and I think in this, I think we link off to maybe it's Mandiant's report here, where that threat actor was targeting IMDS v1, so the older version of the service. So again, throughout all this, we are seeing attackers, are actually starting to understand what to do in the cloud and how to start making use of those vulnerabilities. Publicly, there has been information from security researchers on some of the different, weaknesses of the cloud providers in different ways, or, some of the common misconfigurations they have, but we hadn't really seen attackers taking advantage of that. Something also that's interesting that just came about 2 weeks ago, which was after the release of this report, was AWS actually released a blog post where they mentioned that they've seen ransomware actors actually going after data in S3. So again, we were seeing these attackers knowing what to do inside cloud environments. And the final data point here is that there has been malware that was created specifically to run inside a Lambda. It didn't really do anything interesting within that Lambda, but it was very much written specifically to run inside that Lambda. So that was another thing that we found was interesting. This next section of the report, we talk about some information that's publicly available out there in the world. Anybody could look at this, but we found it specifically interesting to cloud environments. And so kind of the point of this section is you may be, realizing, or finding that in your own environment that it is very complex. Your cloud environment has probably been growing. It has probably been increasing in complexity in different ways. And this is not unique to your environment. So what we're showing here is that this is happening across the board, and it's it's due in part to the complexity and growth of the cloud providers themselves. So what we show here is we look at the SEC filings, so the public financial statements from the different cloud providers, and we look at basically their revenue growth. And so we can see here that the annual growth of the different cloud providers, AWS, Azure, and GCP is what we have shown here. All of them are increasing, which is something that you probably expect and assume. But if you look at the actual finances, like it proves it out here. And this is something that's kind of truth through a lot of our data. Is there's a number of our data points are things that you probably assumed were true, but we are, trying to actually provide the data to show that yes, this is what we see, like with public data, with our own data. So those assumptions, like, we are proving them out for you. And so what we see is that the different cloud providers are growing. Looking at the revenue is a little bit awkward just because for the different cloud providing companies, Amazon, Microsoft, and Google, or Alphabet, when they list out the revenue growth for their cloud businesses, there's sometimes a lot of extra things added in there that maybe you don't want to have in there. For example, for Google's cloud numbers, it also includes things like Gmail or G Suites. And then similarly for Azure, I think it's including like Office 365 and some other things, which maybe you don't think of as being like specifically cloud. Like it's not just Azure, it's not just GCP. But unfortunately, this is the best data that we have that's public for their financial information. The next thing we look at here is the API growth. And so we look at specifically AWS because unfortunately this is the data that we had or that was most accessible. And so we look all the way back from 2016 and we can see basically this count of the APIs. And the way in which we did this was we looked at the GitHub repos for the SDK and basically walked back the commits. And every time we looked at a previous commit, basically did a count of the APIs that are in it, and then just continued that process until we got all the way back to the start of the repo, which was 2016 for the AWS SDK. So looking at that, we can see this just continued growth. You can see that there's these periodic jumps, and these jumps are because of Reinforce. So Reinforce is AWS's annual conference. They release a whole bunch of new services, new features, and with that, there's a whole bunch of new API calls that come about with this. And I think there's a couple things that are kind of interesting here. One is it's pretty steady growth. There's not one year that suddenly it spikes up and then they slow down the next year or anything like that. It is just this constant growth that is happening year after year. And also what I think is important to some other things that are important to realize here is that this is just like the API growth. Within those APIs, they're also adding new parameters. Like the APIs themselves are increasing in complexity. Then you have the APIs that are, there's becoming more of them. There's becoming more services. And so this is just like an increase in complexity across the board here. The other thing that you can see is just how much it has grown. So back in 2016, there were less than 2,000 API calls. And so now at the end of 2022, there's over 12,000 API calls. So the size of the cloud, if you a few years ago had managed to learn everything there is about AWS, if you learned every single API, everything that was possible to know about AWS, a few years later, you potentially only know half as much as what now exists in the cloud. It is just constantly increasing. Unfortunately, today, nobody is able to keep up. A single individual can't keep up with all the information about all the different cloud provider services and APIs that exist. So then we look at the different cloud providers. So we looked at, in this case, we looked at only for the past year. And so this was really just because this is the data that we had. So Ian McKay, he has a project where he keeps track of the different privileges of the different cloud providers. So in this case, we're looking at a slightly different thing. We're looking at the privileges that exist as opposed to the API calls that exist. Really, they're fairly it's more or less a one-to-one. There's some slight variations between them at some points. But this allows us to look at, the differences between the different cloud providers. And so we can see here again, though, like there is growth, there is constant growth. It's kind of interesting to see the differences in the number of privileges that exist. And so specifically that Azure has more privileges than AWS does. That was interesting to me. I didn't expect that Azure has kind of like more complexity than AWS. And you can see both of them, are a fair bit more complex in terms of their privileges than GCP is. But even so, like GCP has over 6,000 privileges. Like that is not a simple service by any means. And so then we start looking at data that we have access to. And so this is things that, we are able to get some visibility into because of our, broad customer base. And so the public statistics that we were able to provide in this is that today, more than 30% of the Fortune 100 are customers of Wiz. And then our data set included over 200,000 cloud accounts. And so this includes AWS accounts, it includes GCP projects, Azure subscriptions, and then also OCI, which is Oracle's cloud, and then Alibaba as well. And so, there's some cases where a customer may have, 1,000 accounts. Another case where a customer may, only have a handful of accounts. And but this is the statistic that we're able to provide. It's always like, kind of difficult to try and, provide some transparency into that information. But we just wanted to try and show that, we do have, fairly broad visibility across this. The next thing, that we show here using this data is we show basically like how many clouds are the different customers actually running on. And so there's kind of this myth out there in the world that there's this concept of multi-cloud. And so, the concept is basically that a customer has an application that runs, on this architecture that spans across multiple cloud providers, and they're able to easily, transition between them, maybe to take advantage of like, cost changes or something like that. And that's really not what we kind of see in our data. And it's very hard for us to, kind of come to precise conclusions. We can't really explain why we're seeing different things. Especially just trying to look at the data, as quickly as we did for this. But what we're able to see is that 43% of customers are operating entirely just on one cloud provider. In this next graph here, what we did, and again, we don't want to show like how many customers we actually have. So we basically broke them into deciles. And so there's basically 10 groups here that each represent kind of a sorted ranking of our different customers. And so what we're able to see is that for 8 out of 10 companies, they have over 80% of their workloads on a single cloud provider. So what all of this is saying is that really customers tend to favor one cloud. So they may be entirely on one cloud, or they may have 80% of their workloads on a single cloud provider. And so workloads in this case means basically the VMs and other compute infrastructure that we can see in their environment. And so what all this means, like we don't know why this is. Like, my opinion, based on what I've seen working at various companies previously and doing consulting work at previous companies, is that a number of customers tend to be using multiple clouds really only because maybe they made an acquisition, or maybe because there is one business unit that really, really, really wanted to use some specific feature that only exists on one of the cloud providers. It's very difficult to try and have a true multi-cloud architecture. Part of the reason for that is because of like the concept of data gravity, where it's difficult to try and move your data to other locations, whether that's multi-region or multi-cloud. Like, it's very expensive, it's very slow to try and move that data around. The other reason, though, is again just that complexity that we showed previously. Like, it is hard to try and know how to best leverage all the different cloud providers. So when companies do tend to try and use a multi-cloud strategy, they end up really using like the lowest common denominator of the different services that are available. And so they're like, we're going to use just compute and just storage, and you're really not taking advantage of all the higher level abstractions and all the kind of differentiating services that the cloud providers are providing to you. The next thing we showed here is that companies tend to have most of their workloads concentrated into a few large accounts. And so basically what this is saying is like the concept of a single monolithic account, which is, known as not being an ideal architecture. It is, kind of best practice to try and make sure that you are spreading your architecture out across multiple AWS accounts or multiple, other accounts in the other cloud providers, partially because of security reasons, so that you can, make sure you're isolating different aspects of your architecture. Also, in larger environments, it also becomes problematic for the quotas that different cloud providers have. But anyways, what we saw is that for over 97% of customers, so nearly every single customer, the largest 5% of their accounts contain over 50% of their workloads. This is kind of a mouthful. And what we wanted to try and show here was that basically there is a large concentration oftentimes of accounts that are the most important accounts, or basically the largest accounts at a company. And so, for smaller customers, they may only have a handful of accounts, and so they may have a single monolithic account. But if you have a customer with thousands of accounts, then it's not going to be one of those accounts is their largest monolithic one oftentimes, but it'll be a handful of them. And so basically we just got the statistics for it to be able to say their largest 5% contain over 50% of their workloads. The next stats we have here is something that I think a lot of people knew, but maybe not to the degree that we were able to show it in our data. And so the statement here is that AWS is the most common platform, Azure is second, GCP is third. And so this is something that I think a lot of people have assumed, or, kind of they knew from other statistics, but I don't know if it's really been seen to the degree that we really saw it in our data. And so we tried to break this down in various different ways. And so these two pie charts here are really, showing two different ways of looking at some data. And what we see in both cases is just how dominant AWS is. Again, this could be some type of bias that we have in our data based on who our customers are, but I really believe that we have a very broad group of customers. There's a lot of them. They're from different industries, different sizes, and we're really seeing that AWS is just such a dominant player. Then we looked at basically like what is the breakdown for who their second largest is and third largest. So in the cases where a customer does have multiple clouds that they're using, like who is the second largest cloud that they're using? And so, we saw that Azure tends to be their second largest cloud. GCP tends to be their third largest cloud in the cases where a customer is using 2 or 3 or more different cloud providers. And then we have this like Sankey diagram, I think is the name for it, which just kind of like shows how this, how it flows between them. Kind of a lot of complex information here, but we just wanted to kind of, slice the data that we were looking at different ways about who is the largest cloud provider, who is the second, who is the third. And so we just kind of provided some stats on that. The next thing we looked at was a mix of the managed and non-managed databases. And so the concept here is that, for example, in AWS, you can use an AWS service called RDS, which is going to be a managed database service, or you can run EC2s and install the databases directly on those EC2s by yourself and manage them yourself, meaning that these are non-managed. They're not managed by the cloud provider for you. And so we tried to basically look at the breakdown of how common it was, and which of the different databases we were seeing most commonly. And so, we saw PostgreSQL used most commonly. Some of these, different databases, depending on your definition, you may not view them as databases specifically, like Redis is an example of that. But anyways, we just tried to break down what we were seeing. And again, just provide some general statistics. Like even though Wiz is a cloud security company, this is not like a security or cloud security statistics by any means. Like this is just some data that we thought was interesting, that we think is generally going to be interesting to other people out there. All right. Now we do start getting into some security information here. And so I think the most interesting thing here, and this is something that we considered just writing like an entire blog post about, but we decided to include it just as a statistic in here, was we wanted to see how quickly do attackers actually find public S3 buckets. And so we ran a couple of experiments. So the first experiment we did was we created some S3 buckets with common or basically common names of other companies out there that we figured attackers probably are trying to breach in some way. So we created one of those names. And then we would have basically the name of that S3 bucket would include dash logs, dash backups, or instead of a dash, maybe it was an underscore or some other type of like prefixes and suffixes and joining characters between them. And so we created some of these different S3 buckets with these names that we expected attackers would find. And part of the reason we expected them to find them was there are attacker tools that exist on public GitHub repos that security researchers have made. Sometimes this is like blue teams at security companies in order to try and find their own S3 buckets. But what these tools do is they try to brute force guess names of possible S3 buckets, and then they check whether or not they're public. So they basically try to list the contents of those S3 buckets. And so what we did was we made these public S3 buckets, and then we monitored them to see when an attacker would try and list them. And so we saw that in as little as 13 hours, I think it was. In both of these cases that I'll talk about is less than 24 hours. But what we saw was that attackers would start listing them. So they would find this S3 bucket and start listing it. So that was one of the experiments. Basically, like how quickly are attackers finding these? Like, are they actually brute forcing? And the answer is yes. Like the only way an attacker would have found these S3 buckets was if they were brute force guessing the name of it, because these S3 buckets weren't referenced anywhere. We didn't mention them publicly. Like we just created them and then waited for an attacker to find them. The other experiment that we did was we created an S3 bucket with a completely random name. So it's all gibberish, hexadecimals and stuff, completely random name. But then what I did was I mentioned that S3 bucket in a public GitHub repo. So I basically just made a random GitHub repo, and then I committed a file to it that mentioned the ARN of that S3 bucket. And so again, what we found was in that case, I think it was 7 hours for an attacker to find that S3 bucket by basically like listing it. And so this was interesting because we've known for a while that attackers are scanning GitHub constantly for access keys. So we know they are looking for access keys, and the second that they find them, they're going to try and spin up EC2 instances inside the victim's environment in order to do cryptocurrency mining. This is something that has been going on for years. And so that is a known problem. And there is actually an integration between GitHub and AWS. They communicate with one another. So when GitHub finds one of these access keys, they actually inform AWS about it. And then AWS is going to quarantine that access key inside your environment. But there is still this race condition where can GitHub find it and report it to AWS, and AWS take action on it before an attacker actually identifies it and abuses it in some way. So that's like a known problem, but it wasn't known whether or not an attacker was actually scanning GitHub for these S3 buckets. And I will say, we don't know if they're actually attackers. We don't know if this is in this case and the other case of the S3 bucket with a common name. We don't know if it was just like security researchers, bug bounty hunters. We don't know if it was blue teams at different companies. We don't know if this is actually attackers. We don't know if this is AWS. We don't know if it is like, some type of search engine that is like scanning the internet, spidering the internet, trying to look for new, web pages to try and crawl. Like we don't know what is happening behind the scenes. Like I looked at the user agent, I looked at the IP addresses. None of them identified who this was in any way. but I make the assumption that it is probably attackers, and in at least some of the cases. So anyways, I thought that that was interesting. Like we did show that yes, attackers are looking for public S3 buckets. They're scanning for them. They're looking at GitHub. They're trying to find them. And we don't know what they would do if they, acquire that data. But we do know that, they are looking for it. And that's it. So that was the conclusion. We didn't really have like an actual conclusion statement here. But anyways, that's what the state of the cloud report is. I guess from here, if you have any questions or anything, you can reach out. Hopefully, our team here at Wiz includes some information so you can try and contact us. But anyways, thank you for listening. All right. Bye.